So let's try to make a video on this whole front side of this practice test. I recommend, if you're in class right now, just maybe not follow along. Maybe just pay attention, and then you try it again later, and you could watch the video later if you get stuck, right? But you want a real understanding of this. So let's jump to number one. Number one says, write the equation in point-slope form of this line that's parallel to this equation and passes through this point, okay? So point-slope form, we need to know what point-slope form is, and that is y minus y1 equals m parentheses x minus x1. Now, when we use this form, I recommend rewriting it with blank spots so you could safely plug in your y1, your m, and your x1 value. Okay, so in order for you to write an equation in point slope form, you need to have obviously your point, your x1, y1, and a slope. So they do give us a point. The x1 value is 2, and the y1 value is -5. So we could begin plugging in the x1 value of 2 and the y1 value of -5. And of course, the negative must change to plus. Now, we do need a slope, though. We need a slope right here. And they don't directly give us a slope. They indirectly give us a slope. They tell us that our line is parallel to this guy. And parallel means what? Same slope. So just a quick review right here, guys, from our notes on this section. Parallel lines have the same slope, the same m value, and perpendicular lines have opposite reciprocal m values. Okay, so this is vocab from the beginning of the chapter that you guys need to know on question number 1. If I give you a parallel line, I'm really giving you the slope. It's the same exact thing. If I'm giving you a perpendicular line, I'm really giving you a negative reciprocal slope or an opposite reciprocal slope. So for example, let's say I told you on tomorrow's test, instead of being parallel, I told you your slope is going to be perpendicular to an equation that had something like -2/3 as a slope. What would our slope be if it was perpendicular to -2/3? Positive 3/2, that's right. You change the sign and you also flip the fraction. You flip the fraction and change the sign. So keep that in mind. Perpendicular, opposite reciprocal, parallel, exact same thing. On this question, I do say they're parallel, so it's going to be the same exact slope, -1/2. Again, the slope is going to be exactly the same, -1/2. And we're done. That is the answer to number 1 over here. So hopefully you're able to squeeze this in right here on the answer spot. Keep in mind that tomorrow, obviously it's not going to be the same exact question. I might give you a different slope right here to give you a different equation. Or maybe I'll tell you to have a perpendicular slope as opposed to parallel slope. So keep that in mind. Let's move on to this next part of the test. This is from section 2.5. It's actually cut and paste from worksheet 2.5. But then again, there's 2.3 and 2.4 involved on question number 3. So let's begin by doing question 2. It says create a scatter plot, graph the coordinates of the given XY table, the given data, and then to draw the line that best fits. So let's understand that this XY table is really an input-output table, okay? And they're really coordinates. So the coordinate 5, 9, right here, you got to be careful because on the x-axis, you're going in units of 5, 10, 15, 20. On the y-axis, you're going by 8, 16, 24, 32. So be careful with that, right? So let's begin 5 on the x, 9 on the y. 5 on the x, 9 on the y is going to be a little bit more than 8. So you're going to put a dot right above 8. And then the next one, 10, 17. 10 on the x, 17 is a little bit more than 16. So you can't put it right at 16. It just has to be slightly above 16. Moving on to 20, 22. So 20, not 15, 20, and then 22. 22 is almost to 24, not quite 24, almost to 24. So let's put a dot right there, almost at 24. Then we're going to move on to 25, 30. 25 on the x, 30 on the y is almost to 32. So put it right below 32. And then 35, 38. 35, 38 is almost to 40. So put it right below 40. And 40, 44. 40 on the x. And remember, that we are going by 8. So right here is 40. 44 is halfway to 48. So it's going to be perfectly halfway in between. So this is our our coordinates, our data plotted onto the coordinate plane. So you get half credit for that. The other half credit comes from the line that best fits. So let's all do a line, and let me do this line right here. Now check this out, guys. If I take this line and I put it through my first, whoops, I can't even get a hold of it. If I put it through my first 2 points, that's not a good line that best fits. If I go through these 2 points right here, that's not a good line that best fits. So if I put it through these two, that's not a good line that best fits. So which one is probably the best 2 points? The first one and the last one. That's a pretty good situation right there, because all those coordinates are pretty close to that coordinate. I mean, that's what you're supposed to conclude. Any questions on that? Now, let's say you don't conclude that. As long as you're able to read instructions, you should figure that out. Why is that? Because if you continue reading, it says, then write the equation in slope-intercept form of the line that best fits using the first and last points on your table. So I'm specifically telling you right here to use the first point given to you, which is 5, 9, and the last point given to you, which is 40, 44. Not only that, I write the word first and I write the word last. Right? I'm telling you what to do here. So if you did use the first point and the last point, you're going to get a great line that best fits. And we're going to use those coordinates to be able to write our equation in slope-intercept form. So this next part right here, you're going to have to show your work here, and you'll probably have to show work below this line as well. You need to know a lot of things to be able to do this question right here. So here are the 3 things that you need to know. Well, if I give you if I tell you use the first point and the second point and the last point, you'll be able to find the slope using the slope formula. You'll be able to get your slope that you just figured out and the first point that we used on our line that best fits, and you'd be able to write it in point slope form. And then at the very end, you'd have to distribute the slope to get rid of the parentheses, move this number over to the other side, and you will be able to change it to y equals mx plus b, which is what they're asking for on this question. So it is a lot to do, but it's pretty straightforward. They want you to use the first one and the last one given to you, right? And the first one, we're going to call that x1, y1, x1, y1. And the last one, we're going to call x2, y2. So of course, when I give you 2 points, the easiest thing to do is to find slope. So everybody, let's jot down the slope formula. M equals y2 minus y1 over x2 minus x1. And let's plug in that y2 value of 44. Plug in the y1 value of 9. Plug in the x2 value of 40. Plug in the x1 value of 5. So when I do the math here, m equals 40 take away 9, that's 35. And on the bottom, 40 take away 5, that's also 35. So luckily, beautifully, the slope is 1. Now tomorrow, it's probably not going to be 1, right? It's probably maybe 2 or 3. But right now, the slope is 1. We have a slope. We definitely have some points. So we could definitely write what type of equation? Point slope form. So let's write down point slope form. So there's point slope form. And of course, when you use it, I would leave the blank spots for you to easily plug in your y1, your m, and your x1 value. So our y1 value is 9. Our m value we said was 1. The x1 value was 5. So that's our point slope form equation. And if they asked for your line that best fits in point slope form, you'd be done. But they're saying slope intercept. They want y by itself. So we're going to go back to this, and we're going to get rid of those parentheses by distributing. So you're going to have x, you're going to have minus 5, bring down the equal sign, the minus 9, and the y. So all we need to do is get y by itself by adding 9 here, adding 9 over there. And here's your slope-intercept form equation of the line that best fits, y equals x plus 4. So that y equals x plus 4 is representing this line that best fits, y equals x plus 4. That's the line that best fits. They also refer to this line as the prediction line, right? Because in businesses, when you make this graph, if you want to predict your sales or whatever's happening at a certain x value, that's what you're going to use. You're going to use the equation y equals x plus 4. Now, if you do go back to the worksheet from 2.5, they say for the input 50, what's the output going to be? I didn't ask you that on the quiz or on the test or on the practice test, and I won't ask you that on the real test tomorrow. On the practice test, I say find the output for the input 60. That's really straightforward, right? What are you going to do? You're going to put in 60 in there, and 60 plus 4 is 64. So that's the answer to number 4. So on your answer column, let's jot down the y equals x plus 4. That was the line in slope-intercept form of the line that best fits. And we also said that when we input 60, we get out a 64. And that's the 3 points that you get for the first half of Chapter 2. Any questions? Let's move on to piecewise functions. This is finally the second half of Chapter 2. It's a little bit more fun. Let's understand what a piecewise function is first. It's 3 different functions, and we're going to be looking at different pieces of those 3 functions. So we really have something like y equals negative 2x. We have something like y equals x plus 2. We have y equals negative x plus 5. And if you're still confused about this stuff, maybe you want to actually write it down. Y equals negative 2x. You could put a plus 0 to let you know that the b value is 0. You might want to do the middle one as y equals x plus 2. And the last one, y equals negative x plus 5 to help you out, right? So the red one, it crosses at 0, and you go down 2 over 1. Again, the slope tells you if it's going up or down, but you always run to the right. So down 2, run to the right 1. And we're going to put a dot right there, and we're going to continue to drop 2 and run 1. And we're going to use that same pattern backwards to extend it in the other direction, right? And normally I would draw my line. Actually, I will draw my line. But if you have a pen, do not do this, right? You need a pencil to do this because you're going to have to erase. So there it is. Now, what's my condition? What does my condition say up here? If x is less than or equal to negative 1. What does less than mean? To the left or to the right? To the left. So if you're really struggling with this, get a piece of paper and cover up the right side. Well, that didn't work. Let me see. Piece of paper. Where's my piece of paper at? Here it is. Go to negative 1, cover up the right side, and that's what you're going to be showing right there. This does have a solid dot right here. See how I put my piece of paper at negative 1 on the x-axis? And I do want to show the less than, which is the left side of it. So I do want this to be a solid dot because it has a solid line, solid dot right here. In that direction, I want to erase everything else. So if a piece of paper helps you, go for it. So let me erase everything else. All right, so let me make my solid dot a little bit bigger. Let's jump to the next part. The next part we're going to do in blue. It says y is x plus 2. So let's go to the 2 and put a dot right here. And what am I going to be doing? Rising 1 and running 1. So I'm going to go from 2, I'm going to go up 1 over 1, up 1 over 1. So let's start plotting the 2, up 1 over 1, up 1 over 1, the pattern backwards this way. Of course, we're going to have to erase. And this is between 2 locations, the location of negative 1 on the x and also 2 on the x. So here's negative 1 on the x, and here's 2 on the x. Does that make sense? Yeah. Now, right here, is this going to be an open dot at negative 1 or a solid dot? Open, okay. And over here at 2, what's that going to be? Solid. So we will have, let me erase these guys, an open dot at negative 1. So here we go. Open dot at negative 1, solid dot over here, and then do your graph. So we really are looking at the piece that is between negative 1 and positive 2. Negative 1, positive 2, from here to here. We're looking at that piece. Okay? And finally, we move on to the third piece, which is y equals negative x plus 5. Y equals negative x plus 5. That guy crosses the y-axis where? 5. The b value is 5, so it's way up here on the edge. And I will be having a slope of down 1 over 1, down 1 over 1, down 1 over 1. And I only want to show the greater than 2. So I go to my x, right? Go to my x, go to 2. With my piece of paper, cover up the left side because I only want to show the right side. X is greater than 2. Here's 2. I only want to show this piece on my green line. I want to erase everything else up here, just show this piece right here. And is it going to be an open dot or a solid dot right here? Open, because it does not have a solid line underneath the inequality. So let's go back, put an open dot right here, erase the rest, and put an open dot at the coordinate 2, 3. Open dot at the coordinate 2, 3. And of course, going that direction forever. That's my piecewise function, guys. That is worth 3 points. Dang, 3 points. That's a letter grade and a half. If you skip this one, the best grade you could get is an 85%. It's not good. Not only that, I mean, we still have more questions related to it. So we're talking about 6 questions on piecewise functions. If you skip this, that's 3 letter grades. The best grade you could get is a C-. So this is very important. Let's really understand it. I did several typos, I apologize, on this practice test, all right? So I already changed it on my computer for future classes, but let's go to this instructions right here, and let's change the instructions. It says use f of x, and it should say above. So use f of x above to answer numbers 8 through 10. That's what it should say. Use f of x above to answer 8 through 10. So please change those instructions, yeah? Okay, so they want us to go to our f of x function and plug in the value of 1. So let's go up here to our f of x function and plug in the value of 1. So is 1 less than or equal to negative 1? No. Is 1 between negative 1 and 2? Yes. So we're going to plug in 1 right here. 1's obviously not greater than 2, so you're not going to plug it in here. 1 is between negative 1 and 2, so we're plugging it in right here. What is 1 plus 2? Answer's 3. Now notice that I did say show your work. So even though this is kind of ridiculous, I would like to see the piece that you're plugging it into. So we said the middle piece is what we're plugging it into, the x plus 2. So I would like you to, yeah, the part of the equation right there. So I would like you to actually plug in 1 right in there, 1 plus 2, and then you write your answer 3 for number 8. Cool? Number 2, we want to plug in negative 2. And we're going to plug in negative 2 into the first one because negative 2 is less than negative 1. So let's show our work. Let's write down negative 2x. And we're going to have negative 2 times x. And the x value that we're plugging in, as you can see, is negative 2. So plug in negative 2 right there. And a negative times a negative is a positive. Okay, again, I don't recommend you guys to be copy machines right now and just copy everything I'm doing. Maybe you just want to pay attention and you could try it at home, and then if you get stuck, you could watch the video again, right? Number 10, f of 5. Let's plug in 5. Where am I going to plug in 5? Into the top one, the middle one, or the bottom one? Bottom one, because 5 is definitely greater than 2, so we're going to go for the bottom one. So I'm going to plug in 5 into my negative x plus 5. And of course, when you show your work here, you're going to go negative x plus 5, and you're going to be plugging in the 5. So that's really a negative 5 plus 5. That gives you 0. So the answer over here on number 10 is 0. Okay, another typo. What typo? Well, down here it says, please graph the following on the answer column to the left. That's great. Instructions are great. But if you notice, this equation is different than this equation. So let's always go with what's given to us where the graph is at, all right? I mean, I already changed this for my future classes. I already changed it for my future classes on my computer. It's already fixed. I need you guys to just scratch that out, and just look at the equation on the graph itself. Okay? When I was making this thing, of course, I was changing things, and I forgot to change these guys according to these guys. I already fixed it on the test. So on the test, this one should match up with that one. But just for right now, let's just go off of where we need to show our graph. Okay, so number 11, that is a absolute value function, and there was a certain form on absolute value functions that we memorized, that we use, where we have a h, a k, and an a, and it's very similar to vertex form. And in case you forgot, I cut and paste straight from our notes on section 2.6. Here it is. I told you y equals a, absolute value x minus h plus k. The most important point is your highest or lowest point, which is the hk value. You have to think opposite on h, and you take k for what it is. And the a value, just like on parabolas, will tell you if it opens up or down, depending if it's positive or negative. And it also makes it wider or narrower, depending on if it's closer to 0 or further away from 0. Okay? So I explained this on our notes. But the thing is, on parabolas, if the a value is 1, we could use the pattern 1, 1, 2, 4, 3, 9. This is not a parabola. This is not a U-shaped curve. This is like a V, right? It's like a V that's opening up or a V that's opening down. So we're not going to use patterns like 1, 1, 2, 4, 3, 9. We're going to understand that the a value is kind of like our slope. That's what it says on our notes. A is kind of like your slope. So let's first begin with the most important point, the hk value. So on number 11, what's your hk value? -1, -2. And I shouldn't say hk value, I should say the hk coordinate, right? The most important coordinate. So let's go to the coordinate -1, -2, which is going to be down here. Now, if you want to continue practicing the axis of symmetry that we do on parabolas, you could do that. You could put a dotted line. You don't have to on these guys, though. But why not? Because we're going to do it on parabolas. You might as well do it on these guys. So what is our slope? Our slope is -1/2. So we're going to be going up or down? Down 1 over 2. Let's put a dot right there. Whoops. Let me stick with the same color. Continue to go down 1 over 2, down 1 over 2. And let's map them over to the other side. So if you didn't want to map it over, right here it's 2 units, 2 units. Right here it's 4 units, 4 units. If you didn't want to map it over, you could go with down 1 over 2, but in the other direction. Whatever you want. This is not an inequality, this is an equation, so we are just going to draw solid lines, or a solid line through those coordinates. Put some arrows, and you're done. Easy peasy, right? Moving on to number 12. This is definitely a parabola, which we need to know vertex form. Vertex form is y equals a, parentheses x minus h, close parentheses squared plus k. Of course, your hk is your vertex. You have to think opposite on h and take k for what it is. And on this particular question, we know that the a value is 1. I mean, some of us are thinking, oh, it's -1. Yeah, but that negative, all it tells you is that it gets reflected over the x-axis, which means that it opens down instead of up. Okay, so we will be able to use the original pattern for a equals 1, which is 1, 1, 2, 4, 3, 9. Let's begin by going with the most important point, which is the vertex. What's that most important point? -2, 4. You think opposite on h, you take k for what it is. So let's go to the coordinate -2 and +4, which is right here. And of course, we're going to draw our axis of symmetry right through that vertex. And I will ask you to state the axis of symmetry equation on the back side of this test. So what would the axis of symmetry equation be? X equals, yep, the x value, this guy right here, the x value of your vertex, x equals -2. So I didn't ask it on this one. Might as well want to practice it. So we definitely need more coordinates. That way we could map those coordinates over to the other side of that axis of symmetry, x equals -2. And this a value is 1, even though there's a negative in front. So that means I will be able to use this original pattern, 1, 1, 2, 4, 3, 9. And maybe we should put the original pattern of a equals 1. Because if your a is not 1, then you'd have to modify your outputs by multiplying by your new a value. But in this case, it is 1. So we are going to go from the vertex 1 over, 1 down. We're going to put a dot right there. Going to go back to the vertex, go 2 over, 4 down. It's going to be down there right on the origin itself. Then you're going to go back to the vertex, and you're going to go 3 over, 1, 2, 3, 9 down. That's 4, 5, 6, 7, 8, 9, right on the edge.
So for this one, we're doing it like slope, and this one is the pattern?
Absolutely. Parabolas have the pattern 1, 1, 2, 4, 3, 9. And on the previous one, that's not a parabola, it's a V. All right, so definitely no pattern on the other one. The other one's like a slope. Okay. Even though the A's both tell you if it's wider or narrower or opening up or down. Anyways, let's map these coordinates over to the other side, right there, and down there. And all we need to do now is draw our parabola. So that is good enough. Now, I know some of us are thinking, well, do I have to draw these dots down here? Yes. If when you plot your coordinates with your pattern, if those coordinates are on the graph, I want to see them. I mean, at the very least, if you stop right here, you know that that arrow has to point to this next point that you have right there. And at the very least, if you stop right here, you have to point the arrow towards that coordinate right there. Okay. Now, let's say you were at your vertex and you did the pattern 1, 1, 2, 4, and let's say 3, 9 would have taken you off the graph, then you don't need to show it. But if your coordinates land on that graph, you better show it. I don't want anybody just showing me these 3 dots right here and saying, oh, there's my parabola. Right? If the other coordinates land on the XY plane that I give you, you need to show them. So that's the first half of this test, explained right here in class. We'll do another video explaining the second half.